Right, welcome back to 2.4, the last lesson in this unit. Well, 3 weeks does seem to be short. It flies by rather quickly. This is the last lesson in Unit 2, and we are going to be graphing the reciprocal of quadratic functions. So really, it's the same idea as how you graph reciprocals of linear functions, but there is definitely a little bit more variety to it. You'll see different cases, scenarios, okay? But the way to do it is exactly the same thing. So we'll just quickly review how to graph the reciprocal of a linear function here. So here it's asked us to graph or sketch the graph of y equals 1 over x plus 2. Now recall what we need to do first is to draw the linear function first, okay? So first draw y equals x plus 2. Okay, so y-intercept is 2, the slope is 1, so we go 1 up, 1 right, 1 up, 1 right, same thing, going backwards, so 1 down, 1 left, 1 down, 1 left, okay, and there is our linear graph. If we join them together, there you go, something like this. Okay, didn't go through all the points, that's okay, I'll just make the points a little bit thicker, bigger, there you go. All right, and now the second step, remember, is to find the invariant points. So 2 invariant points and the x-intercepts, because they are the x-intercepts will become the vertical asymptote, okay? So here we only have one x-intercept, and that is at -2. So here is our vertical asymptote. We would have our invariant points at 1 and -1 for the y value. And then we graph from the invariant points, okay? So to the left of the invariant on the left, so -1. So to the left, the original graph is going downwards. Therefore, the reciprocal graph is going to go up. And remember, it will not touch the x-axis. There's our horizontal asymptote. To the right of this invariant point, the red graph is going up. And therefore, the reciprocal graph is going to go down, right? It's going the opposite direction. To the left of the second invariant point at 1, to the left it's going down, therefore it's going to go up for the blue graph. To the right, the red graph is going up, therefore it's going to go down for the blue graph, okay? And that is our y equals 1 over x plus 2 graph, okay? So again, you draw the linear function first, and then the second step is to find the invariant points, I guess, and then x-intercept, well, x-intercepts, if you have more than one, of course. But we don't for linear functions. Okay, so that's how you do it for reciprocal of linear functions. Now we are going to move on to quadratic functions. Now you could have more than one x-intercept for the quadratic functions, and that really is the biggest difference. Okay, so there's that, and there's one extra point that we need to watch out for, and really that's it. That's the only difference that we are gonna see here. Okay, so if you want to sketch this again, the first step is to draw y equals -x squared minus 1. So I'm gonna do that here. Okay, so -x squared minus 1, this can be written as negative of x minus 0 squared minus 1. So the y-intercept, sorry, the vertex is at 0 comma -1. And this graph is going to go downwards because, or it's going to open downwards because the leading coefficient is negative. Okay, so you can get more points by plug in the x value into the this quadratic equation here. So you could put, because the vertex happens at 0, so you could always just plug in 1, so the point to the right of the vertex, and this will give you -2, and you can also put in 2 as well, so 2 points away from the vertex. That gives you -5. So we'll be here. That's 1 comma -2 and 2 comma -5 here. And remember, because quadratics is a it's a mirror image, it's symmetrical, so then you just need to reflect over the y-axis to get the other 2 points, and there's your parabola right there. Okay, so that's your first step. Second step, same thing, to find your invariant point. So I'm just gonna say IP, okay, too much writing, and the x-intercept, same thing. And for quadratics, I am gonna add one more. You need to find your either maximum or minimum. Okay, now in this case, our invariant point is actually our maximum, right? That is exactly right here. Okay, so that's really, these two here are the same thing in this case. Okay, not always, but in this case, our invariant point is exactly the maximum for our graph. X-intercept in this case, we do not have any x-intercepts. Okay, so couple things here. Invariant point, so I labeled there. X-intercept, there's none. So in this case, there's none. What that means is that there is no vertical asymptote in this case. Now let's think about this. Are we gonna have horizontal asymptote then? The answer is yes. We still have horizontal asymptote at 0, and that is because if you think about these y values, they are all negative y values in our original function here. If we do 1 divided by negative values, it's not gonna all of a sudden become positive. So it will never crosses the x-axis because it won't become positive, right? 1 divided by negative numbers are still negative. Okay, so in this case, we will still have horizontal asymptote. Okay, so then we would graph from our invariant point. So from here to the left, the y values is decreasing, and therefore the reciprocal graph is gonna go up, but again, it's not gonna go through the x-intercept, or sorry, the x-axis. To the right from this invariant point is also going downwards. Therefore, the red graph is gonna go up, but again, will not crosses the x-axis. And there you go. That's it. That is the reciprocal graph of negative x squared minus 1. That's it. Okay, so I will show you one more. Hopefully you don't have, well, again, let me know if you have any questions, okay? I will show you one more, and I'll let you try number 3 and number 4 on your own, okay? Because I do want to show you different scenarios first. I think all these 4 practice questions, they will all look different, okay? Unlike the reciprocal of linear functions, they all look the same, just at a different location. But reciprocal of quadratic functions will actually look quite different in a different scenario. Okay, so the first step is to draw y equals negative of x plus 2 squared. I'm just gonna say plus 0 here, okay? It doesn't really change anything, but what that tells us is, is then we would have our vertex at negative 2 comma 0. So, okay, fine, I'll try to make it actually on the, there you go, negative 2, 0, right here. Here is our vertex. This graph again opens downwards because of the negative sign there. Okay, so then again we can find more points by simply plug in, because that the vertex is at negative 2. So I'm just gonna plug in negative 1 here, and I'll get a value, and then I'll put a 0 in there, so I'll get another value. So this is negative 1, this is negative 4. So I would have a point here, and I would have a point right here. And again, it's a mirror image. So if excuse me, if we just reflect over the axis of symmetry, which is at negative 2, x equals negative 2, and there's our other 2 points. Okay, so it's symmetrical. Okay, something like this. So this is y equals negative of x plus 2 squared. Now again, we move on to the second step. We would need to figure out our invariant points and x-intercept and the maximum or minimum. Okay, invariant points, we have 2 in this case at negative 1, right? These 2. We would have a x, we do have an x-intercept, and in this case, x-intercept and the maximum is actually the same point, okay? But that's okay. We would have a vertical asymptote at negative 2 because that's our x-intercept. Okay, now from here this invariant point to the left of that invariant point, the red graph is going downwards. Therefore, the blue graph is going to go up. Okay, so again, it's always the opposite. That's the same regardless of reciprocal of linear functions, reciprocal of quadratic functions, cubic function. That doesn't matter. It's the same thing. To the right from that invariant point, it's going up. Therefore, the blue graph is going to go down. Okay, it's the opposite. And then from this second invariant point to the left, it's going up, and therefore the reciprocal is going to go down. To the right, this is going downwards, therefore the reciprocal is going to go upwards, like this. So you can see this reciprocal graph is quite different from the reciprocal graph that we had for the first practice, okay? So that's what I'm saying. The concept is the same, but because of where the original parabola locates, it actually looks quite different for your reciprocal graph. Okay, I'm gonna ask you to try number 3 and see how it goes. Okay, so go ahead and pause the video and give it a try. Okay, so I'm assuming that you're finished. Hopefully you try yourself. Okay, I think it is actually absolutely critical that you try yourself first. It's okay if you made a mistake, that's not a big deal, but I think that you should definitely try it. Especially these ones, they are all different, right? They have different scenarios. Okay, so first step, draw y equals negative x minus 2, x plus 2. So in this case, we would have two x-intercepts at 2 and negative 2. We can find the vertex quite easily in this case because remember, it's a symmetrical graph. So vertex, the x-coordinate of the vertex would be like halfway between these two x-intercepts. And the x-coordinate of, the x-coordinate is right in between, the halfway point between these two x-intercepts would be 0, right? So your vertex would be at 0 and whatever the y value is. So then you just plug in 0 in here, 0 minus 2, 0 plus 2. I believe you get positive 4. Okay, so there is your vertex. Okay, so again, vertex would happen halfway between these two x-intercepts because it's a symmetrical graph. Okay, so oops, I completely missed it. That's really all I need. Okay, that's all I'm looking for. 3 points. That's good enough. Okay, for me. All right, so here is your parabola. Now, second step. Again, the second step is to find your invariant points. What else? I forgot. X-intercepts. Oh my goodness, brain froze right there. And then the max min. Okay, in this case, you can see all these three are all different. Okay, the inflection points. Sorry, not inflection point. The invariant points are actually 4 of them. Here is the negative 1, here's the positive 1, here is positive 1, and here is negative 1. Okay, so there are 4 invariant points. We have 2 x-intercepts, and they are at negative 2, so we would have our vertical asymptote right here. We would have our vertical asymptote right here. Okay, because they are the x-intercepts. We have a maximum in this case. Now, if you think about this, if the bigger the number is, when you do reciprocal of that, it becomes very, very small, right? On the other hand, if the original value is really, really close to 0, the reciprocal of that is going to be really, really large. So the reciprocal of the maximum really becomes the minimum, okay? And the reciprocal of the minimum becomes the maximum of the reciprocal graph, okay? So here, this is 4. That's the maximum. Maximum is a 4. This is the maximum, and this will turn into a minimum, okay? And this will turn into a minimum for reciprocal graph. Okay, hopefully you can see it. Oh, I missed it. Well, for reciprocal. Okay, so that's 4, right? The y value here is 4. The reciprocal of 4 is 1 over 4, which is 0.25. So let's say somewhere here. Oh, somewhere here. All right. Now, again, what you need to do is to graph from the invariant point, okay? So from my very first invariant point from the left to the left, it's going down, as you can see. Therefore, the reciprocal is going to go up. And again, we would have our horizontal asymptote right here as well. To the right, you can see the blue graph actually goes up. Therefore, the reciprocal is going to go down. Okay? From our second invariant point to the left, the blue graph is going downwards. Therefore, the red graph is going to go upwards. To the right, you can see it's going up until the maximum, and therefore the reciprocal is going to go down to the minimum. Okay? From this third invariant point to the left, it's going up. Therefore, the reciprocal is going to go down to the minimum, just like it was going up to the maximum. Opposite of that, right? And then to the right, from the third invariant point, you can see it's going downwards. Therefore, the reciprocal is going to go up. Okay, continue to the last invariant point. To the left, it's actually going up. Therefore, the reciprocal is going to go down like this. It's kind of tight. It's difficult to see. But to the right, you can see the blue graph is going downwards. Therefore, the reciprocal is going to go upwards. Okay, so looks like that. So it really looks like this. If I draw it on, it looks something like this. Okay, looks something like that. Okay, so that's the reciprocal of this particular quadratic function. Okay, watch it again if you don't understand. Otherwise, if you're okay with this, try the next one here. Okay, this one also looks a little bit different than the previous three. Okay, so give it a try. Okay, so same thing. First, draw this. Draw x squared plus 2. So it looks like this. I'm gonna do it quickly here. Here's my y-intercept. If I plot the next 2 points, I should get 1 here, and I should get 2, 3, 4, another one here. 6. Yes. So, and then it's mirror image, so right there and right there. Okay. Hopefully you know how I got these 4 points. Okay, so that's my first step. Okay, now let's do the second step. Like I said, it's always the same inflection. I always say inflection point. Okay, brainwashed in calculus. Okay, anyways, invariant points. What else? X-intercepts, right? And then the last one is the max or min. Now in this case, you see there's no invariant points because there's no 1 or -1 for the y values for this graph. There's no x-intercept. However, we do have a minimum in this case. Okay, we do have a minimum, and the minimum is at 2. So what happened then is that really this is the only one that we can work with. Okay, the minimum is not going to be 1/2, right? Because this is not going to be a maximum now, right? Because the reciprocal of a minimum is a maximum. So we would have a maximum at 0.5 here. Okay, now to the right from this minimum of the red graph, you see to the right, the graph is actually going upwards. Therefore, the blue graph is going to go downwards towards the asymptote, horizontal asymptote. Okay, to the left from this minimum for the red graph, it's going up. Therefore, the reciprocal is going to go down. Okay, it's kind of hard to show that it's going downwards and difficult to show that's a maximum, but that's basically what it is. Okay, you can see this again looks different from the first 3 cases. So there are just different scenarios. Okay, you really just need to use the concept to graph it, not to memorize what they should look like, because there are just many different cases. Okay, all right. Okay, hopefully that's okay with you. We will do the last kind of example, which again is like going backwards. So let's take a look. I'll do the first one and I'll let you try the second one. So here it says use the graph of the reciprocal function to graph the corresponding quadratic function. So again, this is y equals 1 over f of x. And we are looking for what, well, I guess we're not looking for the function f of x. We don't, okay, we're not doing that, okay. We could, but we're not, okay. we are just going to draw the f of x, which is the quadratic function here. Okay, so again, going backwards, we are going to look at invariant points first, which would be here. Oops, sorry, here and here. And then, because you can see clearly, we would have a vertical asymptote at 1, so we should have an x-intercept at 1 here. Okay, now, well, there you go, that's it. This is the vertex. And how do I know that's the vertex? Again, because this point, the x value here, is the halfway point between these two same y values, right? These two y values are both 1. And the halfway point for the x between those two invariant points would be where the vertex is, because it's symmetrical, right? So there's our parabola right there. Okay, we could find the equation of f of x. It's f of x equals x minus p squared plus q, and here's a in the front. I said we don't have to, but you know, I'm just gonna do it. Why not? A x minus p, the x coordinate for p is 0, q, 1, not 0, and q is 0. Okay, now we can solve for a by, again, plugging a value, a point, into the equation. So I'm just gonna, I'm not gonna use 2, 1. We should always use x-intercept or y-intercept if possible. Okay, because you got a 0 there. Okay, so y is 1, and we don't know a, but 0 minus 1 squared. We don't need to write the plus 0 because it doesn't do anything. And this gives us 1 equals a times 1. That means a equals 1. So our equation, if it does ask you, would be x minus 1 squared. Okay, that would be the f of x. Okay, so let me know if you, let me know if you have any questions. Otherwise, try part B. Okay, so I'm assuming you finished part B. Similarly, again, we are going to find the invariant points first, and that'll be right here, and right here. We are going to find the x-intercepts because from the vertical asymptote, and that's right here, and that's right here. So then, again, this right here would be the vertex. And that is because, again, here are the two x-intercepts. This x value is right between those two. So that has to be the vertex. And there is our parabola right there. And again, we can easily find the equation. Okay, f of x then would be a x. I guess it's just going to be x squared because, well, you know what, I'm just going to write x minus 0 for now. Squared minus 1. And then we can use the x-intercept. In this case, I'm just going to use this x-intercept, 1, 0. So y value is 0, a we don't know, so x is 1. 1 minus 0, we don't need to write the minus 0, I guess, minus 1. Bring 1 over, you get 1 equals 1a, therefore a is equal to 1. So your equation is f of x equals x squared minus 1, and that is your f of x, if the graph was 1 over f of x. Okay, so that will conclude this lesson, and this really is it for this unit. Here are some questions for you to try, and let me know if you have any questions during the office hour, or just send me an email or something. Oh, send me a message on Teams. Okay, good luck.